a story first, and then after we close the streaming, you volunteers can try this mobile device. So I think we will be hearing and seeing something about virtual reality or augmented reality and how AI is boosting that. Is your presentation working? Looks like. Do you mind using the hand mic?
Yes, I prefer mic rather than shouting. Yeah, that was brief introduction. So I'm happy to be here, and like Petri said, I'm always here because our office is over there. So I'm going to be talking about seamless AR experience through location awareness. We are not really an AR company. We are an indoor positioning company. But I'm talking about AR because our indoor positioning is an enabling technology for all kinds of AR applications, and we'll come to that in a minute. So basically, what we are doing is computer vision based indoor positioning. So in order to locate a user, the only thing that we need is a mobile phone. So we are not relying on any beacons or any hardware. It's totally software-based solution. We have a cloud software doing the actual positioning, but then we need only the application software in the mobile phone. So what that means is that we are not using any markers. We can get AR accuracy without markers. It's not totally in the same level yet. Well, you will see in the demonstration how it works. So in our case, the AR objects are not anchored to any markers as in many AR solutions. We are not using any surface detection like Google AR Core and Apple's AR Kit are doing. We are rather using, if you think the whole environment as a marker, that is how we are anchoring all the AR objects. So that means that the objects are visible to all users in exactly same places, and of course that makes navigation with AR possible, and that's all about in our demonstration as well. So this part we do partially. So what is the actual AR content that we are showing? So this is more like just what is being enabled with our technology, having right data in right place, meaning physical place. In our case, the AR objects are mapped in the 3D model that is located in the cloud. So that means that the AR objects can be added even remotely, which well, that can be used as a collaboration tool for workers. How we do this all? That requires creation of a 3D model in the cloud, and that is created automatically based on the video recording with the ordinary mobile phone. So the video is uploaded to the cloud, and that automatically creates the 3D model. At the same time, we can, to a certain extent, map also some objects into the 3D model. So that increase the richness of the 3D model, so that we know location of various objects. Then the actual navigation is based on pointing somewhere in the space with the mobile phone. The phone application sends images to the cloud server, and that compares the image to the 3D model and returns XYZ coordinates of the user and also the locations of the objects. So that can be used for navigation directly, but also for adding location-based AR content. And that is something that I have tried to visualize here, that there can be various kinds of AR stuff in the camera view. Key applications where our technology can be used, we have identified quite a lot, because basically all indoor AR that is required to be location-based can be implemented on top of our positioning technology. So there are industries, activity parks, shopping centers, real estate management, all kinds of public places. The only thing is that we don't currently do anything outdoors. So we are working only indoors. There's one example from industry. Just 2 weeks ago, we happened to be one of the 4 winners in Valmet Innovation Competition, and this was the proposal that we made them for that competition. So it is seamless factory scale AR. So even though you are moving your mobile phone, the AR objects stay in place because they are attached to different locations. There can be manual pages, there can be exploded views of various machines, there can be IoT data in the view. There's something alarming here, and since it's not visible in this mobile phone, it's showing that, okay, turn your camera that direction and you will see where the alarming sensor is. This example is from a shopping center. There we can provide navigation, we can provide IoT data, we can show special offers in front of different stores. For example, there can be some treasure hunting games, for example. That is one way to get people spend more time in the shopping centers. Well, this diagram is a recent pilot or actually ongoing pilot in the airport, where we are assisting passengers to find different places in the airport. Third example is AR games. We can provide for example, shopping centers or activity parks, these kind of AR games where you hunt treasures and try to avoid monsters. The thing that we can do that most of other AR technologies can do is that we can make these monsters, for example, move, because they are tied on location, so we can easily change the location and then they start moving. Okay, well, here I have, if I can make it visible, okay. This is about the same demo that you are going to see if you wish. So it's a navigation demo in this premise. So that is roughly how the 3D model looks like in the cloud, and then you write there that you want to find a coffee machine, and since it knows where the coffee machine is, then it starts to guide you to the coffee machine with the AR arrows. So in our demo, you will see similar type of arrows, and there is actually at least one AR object hidden somewhere here. So you will have the possibility to try to find it. Okay, well I think I will terminate here if there's any question. By the way, Marius over there is the guy who is mostly behind the technology. So Marius and me, I have also a phone that has the application downloaded. So we will show you the demonstration, and I think we will start from somewhere over there. I think because this is too crowded, and yeah, the actual reason is that well, of course, since we are comparing the image from the camera view to the 3D model in the cloud, if the environment changes, then it's harder to recognize where you are. So we are not sure how much this audience will affect. So let's start from over there.